Greetings to you guys. Welcome to our mathematics revision class. Once again, we are focusing on grade 12 mathematics, particularly differential calculus. In this video, we are discussing differential calculus with a special attention to first principles. Mathematics paper 1. This is one of the sections where we can all pass with no problems because the questions there are straightforward. You need to follow certain steps to be able to do them. If you study and practice, it should work out for you. My name is Mr. Tauseni, mathematics teacher. If you need us to make any video for you, or if you need any worksheets or notes or explanations, please don't hesitate. You can contact me on the number that is showing on the bottom there. That is my WhatsApp number. Contact me there. We can definitely assist you with whatever that you may need. All right, let's start with the first principles. Now, in this particular section, our calculations are done in parts. When I want to differentiate from first principles, we are not going to back to the background of what is first principles and how to derive the formulas and stuff like that. We did that in our previous video. So in this particular one, we're only focusing on application of the formula, using the formula to differentiate. So first of all, you need to calculate the value of x plus h. F of x is equal to x cubed. So x plus h simply means in this expression, you remove x and replace it with x plus h, such that x cubed becomes x plus h cubed. That means the whole bracket x plus h will now multiply itself 3 times. So you have to expand this using the FOIL method and simplify to its simplest form. Calculate the value of f of x plus h. The second calculation, we determine the value of f of x plus h minus f of x. What it means is, in our previous calculation, we have calculated f of x plus h. We go back to that expression, and from it, we subtract the value of the original expression, which is f of x. So it's going to be x cubed plus 3x squared h plus 3x h squared plus h cubed minus x cubed. And then you simplify to simplest form. The next one, which is the third calculation, you substitute into the first principles formula. The first principles formula says the derivative of f of x is equal to the limit of f of x plus h minus f of x over h as h approaches 0. Now, if you look at our expression, you'll see that in the numerator here, we have got f of x plus h minus f of x, which is exactly what we have calculated in our step 2 in our previous calculations. So when we do our substitution, we're just going to take this expression here that we calculated in number 2 and plug this one into the entire numerator of our expression. So now our derivative will become the limit of 3x squared h plus 3x h squared plus h cubed over h as h approaches 0. This numerator is coming from the second step of our calculation, where we determined f of x plus h minus f of x. Then to carry on from here, when you get here, to just make sure that your calculations are correct, you must have this entire expression. It must have a common factor h. If h is not a common factor of your expression, there is a mistake in your calculation that you may probably need to rectify. So from here, we factorize h, factor out h. H is a common factor. After factoring out h, the h that we have factored out is divided. It's divided. This one is x cubed. Apologies for that error, h cubed. You divide this h out. After dividing the h out, the remaining h is substituted with 0. So put 0 in place of h. So this will become 0. This will become 0. Then we have our derivative, which is 3x to the power of 2. Then our answer is complete. So that is the differentiation from first principles. So just to quickly determine f of x plus h, that means you are replacing x with x plus h in your expression, and you simplify. Then after that, determine the value of f of x plus h minus f of x. That means in our previous expression, we're simply going to go back there and subtract the original terms of our expression, and then we simplify. The third part is substitution into the formula. We substitute into the formula, then we factor out h. After factoring out h, we then replace the remaining h with 0 to get our answer. That's differentiation using first principles. Very nice and cute. No stories with this one. We look at the same expression done in a slightly different way. Now, in this particular one, we can go straight into the formula. The derivative is equal to the limit of f of x plus h minus f of x over h as h approaches 0. So the first part of the formula, the x plus h, it means we substitute x with the x plus h in our expression. So x cubed becomes x plus h cubed. Then we are going to expand that entire bracket. Then this x cubed here is my f of x. So in place of f of x in this expression, I'm going to have x cubed. So the first part is f of x plus h. The second one is f of x. Then we subtract them. So before we subtract, obviously, you have to expand this bracket by the FOIL method. So after expanding it, we subtract it. You will see that in every term, there is h as a common factor. Factor out h and divide it. Then the remaining h becomes 0 and our answer will be determined. The answer to this question is equal to 3x squared. We have differentiated using the first principles. So you can do it in parts like in the previous explanation, where you calculate f of x plus h, then you calculate f of x plus h minus f of x, and then you substitute. Or you can substitute straight away into the formula like I've done in this video, in this section. Your answer will definitely be the same. Let's have a look at one more example. Let's say we want to differentiate f of x is equal to x squared. So if I do it in parts, I start my calculation by determining f of x plus h. That means we are replacing x with x plus h. So x squared becomes x plus h squared, which needs to be simplified using the FOIL method. That will give us x squared plus 2xh plus h squared. Then our second calculation, we determine f of x plus h minus f of x. We are going to subtract f of x from our previous calculation. Then we simplify to simplest form. Then the third one is substitution into the formula. So the derivative of f of x is equal to the limit of f of x plus h minus f of x over h as h approaches 0. Then in this formula, the numerator is what we have determined in step 2. So we're going to back to step 2 and remove this numerator in our formula and substitute. So our answer will now come through very nicely there. So the derivative will be the limit of 2xh plus h squared over h as h approaches 0. Then factorize. Remember, we said if h is not a common factor of your expression here, then there is a problem somewhere. We have to factorize this. Then the h that we have factored out is divided. The remaining h becomes 0. Then our answer is equal to 2x. That is the derivative of f of x is equal to x squared. And the method that has been applied here is the method of first principles. So when you're in an examination,